test fails. So you can check with other tests. Is this clear?
Yes, sir.
Alright. Then
Max, for also this initial place, still very close to the
yes. So you can also have the nth root test. So we call this Graham's test. Now we have the nth root
No, I
test.
haven't done it this semester.
Last semester.
So nth root test, you want to get the limit of nth root of a sub n, modulus of a sub n. Okay. So if we say that, of course, as n approaches infinity, so we say this is equal to alpha. If it's convergent, if alpha is less than 1, and if alpha is greater than 1, it is divergent. And if alpha is equal to 1, test fails. You get that? You get it? Okay. So when is this appropriate? This is appropriate when you have something raised to the power of n. Are we together? So it will help you clear off that power of n. So anything raised to the power of n, it will help you clear it off. Is that clear? Alright. So you can also have what we call functional series. So
Max, what's this now? Max, you want to send Lano?
don't run, no, please. Why are you calling her Lano?
Is that not the pronunciation? I said, I just said Lano. I don't go call you Lano. Lano from
Mama is proud of me.
Who is proud of me? Give me breakfast.
I'm trying to understand.
What kind of breakfast?
Max, I love story.
That is another this one. So before we talk about functional series, let's solve a problem. Determine whether or not the following series converge. Determine whether or not the following series converge. Look at this. You have this series A n equal to 1 to infinity n over n squared plus 1. You have B. So firstly, tell me what kind of test is appropriate for each of them. What kind of test will you use for each of them? N equal to 1 to infinity. So we said this one is starting from n equal to 2. Okay, to infinity. Of 1 over n ln n.
Which one?
Then the next one is summation from n equal to 1 to infinity of n over e raised to the power n squared. So that's going to give us next one, D.
just shoot like a fool. You need to give all the people.
What is it?
1 over the fourth root of n. Alright.
Maybe a facial expression.
Exactly.
So which of them is convergent? So what kind of test will you use for this?
Series test.
The divergence.
Nah, comparison.
What kind of test will you use for it? I'm not asking you if it's convergent or not. Comparison test. Okay, you're comparing with what?
N squared. 1 over n squared.
Is it always greater than 1 over n squared or always less than 1 over n squared?
Oh, God knows.
You compare 1 over n.
You compare with 1 over n? Okay. Is it always greater or always less than? Only God knows. Only God knows.
I mean,
It's going to be less than. Okay, if you try, you can try to reduce it or try to increase it, Abi. Look at something, look at something. N over n squared plus 1, Abi. The only thing you are sure is that what? It is less than n over n squared. And n over n squared is what? This is equal to 1 over n. That means it is less than 1 over n. Abi? What can you say about 1 over n? That's a P series with P equal to 1. That's divergence. Abi? So it is less than a divergent series, so you can't conclude. You can't reach any conclusion with that. If it was less than a convergent series, we would say it's convergent. Do you understand? So you can't reach any conclusion by making a comparison.
I say, I don't understand.
So what will you not divide?
Can you repeat that you just said? So if it is less than a convergent.
Yes, if it's less than a convergent series, you cannot reach. If it is less than a divergent series, you cannot reach any conclusion. Something that is less than infinity, we don't know whether it is infinity itself or it is some real number.
If it's less than
If it is less than a convergent series, then we know that it is convergent.
it's less than a divergence.
Or it is greater than a divergent series, we know that it's also divergent. Does it make sense? Okay, so we cannot conclude with this comparison test. Okay, so what else do you think we can do here? What else? Huh? Ratio test. You can do an integral test. So you should notice that the derivative of the denominator is 2n, Abi?
Yes.
So you can easily integrate this. Do you understand me? So you can write this as integral of, say, x over x squared plus 1, the x. Okay. You can take that from 1 to infinity. Is that clear? This is going to be equal to integral of x squared plus 1. Then I want to make this 2x. Then I put 1 over 2 outside the x. Does that make sense? I just want to ensure that this one is derivative of this. Is that clear? So it becomes very easy to integrate. This is just going to be 1 over 2 ln x squared plus 1. Does that make sense? Then we are going to run the values from, what's it again? From 1 to infinity. So this is going to be from 1 to infinity. And if you want to do this, you know what you should do. You may not be able to include or put infinity directly. So what you do is this: you find, please pay attention now. You find the limits as use some number to represent infinity. Let's say m approaches infinity of this. This is 1 over 2 ln x squared plus 1. Okay, then from 1 to m. So that means I will use something to represent infinity first. When I get the result, then I'll take the limit of that result as m approaches infinity. Does it make sense? Does this make sense? Does it make sense? Instead of substituting infinity directly, okay, which may result in more problems, we'll put in m first in place of infinity. Then when we've gotten our result, we take the limit of that result as m approaches infinity. Does it make sense now?
Yes.
Okay, so what will this give you now if you make substitution? So this is going to give you the limit as m approaches infinity of it's going to be 1 over 2 ln. So this is going to be ln. We're putting this one, that's m squared plus 1 minus ln.
Max.
Yeah?
It's not showing the camera.
What do you say?
What shall is not showing the camera?
Hey, I want to put
Just that part, just that part.
Okay, this part, Abby. So I should move up. Where's our cleaner?
And then this guy.
Oh.
It goes to each like 3,000.
So what will this give us now? That's going to give us the limit as m approaches infinity of this expression. I can have 1 over 2 right there. I can even bring out the 1 over 2. This is 1 over 2. So this will now be ln m squared plus 1 okay, minus ln 1 squared plus 1. Then I close the bracket. You understand what we're doing here? You understand it? Alright, so this is going to be 1 over 2, the limit as m approaches infinity of this is going to be ln of this minus ln of this. That's ln m squared plus 1, Abby, all over 2. Do you agree with that? Rules of logarithm. Is that clear? Is this clear?
Yes, sir.
Okay. So what's the limit of this as m approaches infinity?
Infinity.
That's going to be infinity, Abby?
Yes, sir.
Alright, so that's going to be 1 over 2 multiplied by infinity. So at the end of the day, you have infinity. So you can see that. That means what? The series diverges. Is that clear? Diverges. So if it gave you a real number, that means it is convergent. Can you remember that? Alright. So that means that what? Therefore, the series from n equal to 1 to infinity of 1 over n, n over n squared plus 1 is divergent.
Goes to
Ask on that. She did. Max. That integration,
Okay. That's why I told you to go and learn integration. Whenever you have this situation where the numerator is the derivative of the denominator, just take the lane of the denominator. That's it. Oh.
So you thought it's different.
That's what it is.
yeah.
That's
It's not like
Your own is at where?
you just go put us for outfit.
What's our Ah, the time of fix
Go to like just one picking. I want to know if they do that.
you be happy.
Can we move on?
No. Ah, physics.
I'm doing accounting. So physics is not my
Is it chemistry or industrial chemistry?
She said, but she just goes.
This kind of says they need accounting and financial.
Industrial.
Accounting.
See now we can't need. We need ME 20 to do what?
Let me see. You see in accounting.
Okay, ME203 is meant to be computer graphics, but then you don't have the facility to do that now.
Let me show 3.
203, yes. You're meant to be using computer graphics. Everybody into engineering design will need that.
Exactly, we're not even nobody's using paper.
It used to be paper, now it has to do with computer. It's AutoCAD, Autodesk. That's
Now
what
because
they
you
use.
don't sabi the paper one now.
Which one is because you don't sabi? If you start using with the graphics, you sabi too.
Na so.
Sure, Sabi.
Shade is good for people.
Na so.
Calms down. Because the, you know what I mean, she now goes in.
Can we move on? So look at the next one. What kind of test can you use?
Pressure going by one.
What kind of test?
Number 2, let's use ratio.
One test. You should use one test.
That means comparison.
Which one is one test? Who taught you that one? I should pick anyone. I want to pick. Comparison. Okay, you are comparing with what?
We compare with 1 over n squared.
Okay, so is it less than or greater than 1 over n squared?
Do it.
That one is
What we're comparing is 1 over n squared.
n is always
Okay, one thing you should know is that n is always greater than ln n. Abi?
yes.
If n is always greater than ln n,
1
1 over n is always less than Abi? 1 over ln n.
You multiply everything by
So you multiply everything by
1 over n.
My brain, you know, supposed to come to do that.
multiply everything by 1 over n. Okay, that's good. If you multiply everything by 1 over n, that's 1 over n squared equals to 1 over n ln n. So what can you say about that? You cannot conclude. Abi? Yes. This is convergence. And it is greater than the convergence series. Do you see that? You can also say that 1 over n ln n, of course, it won't work. You can also say this is also going to be, what's it now? Is it less than? Yeah, less than 1 over n. Does that make sense? Do you get that? Instead of multiplying this denominator by ln n, you are choosing not to multiply it by ln n. Do you understand that? That means that the denominator here will always be lower than the denominator here. Are we together? Or it will be lower from some point forward. Anything above e, which is fine. But then, this is divergence. Abi? It is less than the divergence rate, so you still cannot conclude. Do you understand that? Alright. So what's the next thing? Another thing you should observe is that actually what you have here, 1 over n ln n, is the same as 1 over n then divided by ln n, where this is now the derivative of this. Do you notice that? Do you get that? Yes. 1 over n is derivative of ln n. Abi? Yes. That means you can integrate. Yes. Is it clear? Do you understand?
When the time table thing goes say
you can integrate. Okay, with respect to it. So do that. Do the integration and find out if it is convergent or not.
people know when they come with the action, people just come. You never need to go to people like this.
Most are doing it now. That's the same thing.
No, they tell me that the time you use yourself, the time person will give us they will give you. Why they go give you this kind of thing? We are not saying they don't give us all this kind of thing.
This is from last year question now.
Eh? Then you say that this guy will give us
Like these four questions.
No,
Like,
it
you see
won't be exactly like, but it will be something of this caliber.
yes. If they say cos n squared.
No, thing is,
That man, I feel that man we call us out that is. Now he be MTH coordinator.
Somewhere that guy is remember your face.
Ah, guy, I see.
That would be infinity minus shit. Leaning one, I know it is.
I mean, what's he doing? Yeah, I mean, what's he doing?
Number B.
You stay for
I know. Zero.
Shall I?
Zero.
What's that about it?
This zero is minus infinity.
So what happened?
On one side it's not a real number. It's not
No,
like
this is
What did you get?
infinity plus infinity.
That's infinity now.
so all our answer.
That means it's divergent.
Oh.
Wow, we sabi all this one, but no sabi how to waste it. We sabi if you could divert the thing, but to reach that place, I will time big barrier. I never do it. You know what I did? No reason how they put it out.
I said numerical, you don't numerical, just like that.
What if you get to the exam and they give you theory questions?
Sir?
So the should be HB pens.
Okay, that should be it. Okay. Hey, what if it's theory and
No, just bring only. They said HB pencil only.
you will now see part A.
No.
Part A will be limits, continuity, differentiability, sequences, and series. Then part B will now be differential equations, numerical methods. This exam is not for me. You will leave your exam for them.
Can you make all the do MTH?
Oh, you're on the name.
What I go do ME? You won't kill me. I just go to one question and we change all this stuff. Differentiate this one. You sabi now? Let me know what it is.
Can we move on? What did you get? So everything we have been doing, this one is, what was this one? Okay, this one is divergent. What of this?
So I solve it now. So I solve it now.
You are meant to give it a try first.
No, the B I didn't get it.
Okay, the B, you didn't get it.
Yes.
Yes. Oh yeah. That's going to be integral of 1 over x, Abi, divided by ln x, the x, so from 2 to infinity. Do you understand that?
So why are we using 1 over x?
It's the same thing as 1 over x, ln x. Did you get that? So we could just put this there. So this is going to give us, the integral of this is going to be ln of ln x. Do you get that? Do you understand that? Do you understand this? Then you want to find out what this is from 2 to infinity. And I told you to just use m, then get the limit of this as m approaches infinity. Okay? So this is going to be equal to the limit as m approaches infinity of, so this is going to be ln of ln m, okay, minus ln of ln 2. Okay, so what would that give us? This is going to be, if you like, you can combine those two. This is going to be limit as m approaches infinity of ln m. Okay, so you can have this to be ln m over ln 2. Does it make sense?
Yes.
And
Yeah.
with that, you are good to go. So if you have ln m over ln 2, what can you say about that?
The number is a constant.
So you can write this as limit as m approaches infinity of ln log m to base 2. Does that make sense?
It's done.
Does it make sense? Have you seen something like this before?
We will see.
Rules of logarithm now. If you have log a to base b, or say log a to base c, divided by log b to base c, you can simply put it as log a to base c. Can you remember this? Have you seen this before? Okay, you have not seen it before. Okay, now you see it. This is log to base e, log to base e. So they have the same base. You can just put them together this way. But it's fine. Whatever you take it to be, it's okay. Then as m approaches infinity, this is going to give you infinity. Ln of infinity is going to give you infinity. So at the end of the day, you are going to have infinity. So since it is not convergent to a real number, we say that this is divergent. Is that clear?
Right, sir.
So the series is divergent.
Max, can you explain that mean cos bracket in x? That one over x over x.
This one?
Yes.
And now this is derivative of this. You agree with that? Derivative of ln x is 1 over x. Just like we solved this one earlier. I would say this one is derivative of this. Look at this one that we did earlier. So the integral is just going to be ln of the denominator. Did you get that? So in the same manner, this is just going to be ln of the denominator. The denominator is ln x. That's how we came about that. Whenever you are able to separate it out that way, such that the numerator is derivative of the denominator, you can always take the ln of the denominator. Is it clear? Alright, let's move on. Let's move on. So that means the series is divergent. Is that clear? It is divergent. That is that, about that. So look at the next one. C. How would you approach C? What, which of the tests do you think will work for C?
One test.
Yeah.
This series.
I just still using now, actually.
I can't see it.
Can we? So it's
Can
okay
we
now.
serious?
Can we use?
Ah, you see.
By it here.
Yeah, that is the problem. I'll tell you.
Oh, E is the problem. No. So, if you did not have square, okay, you probably want to do a ratio test. I mean, if you didn't have that two there. Do you understand what I just said? Okay. So, in this case, what you can actually try out is the nth root test. All together, the nth root test. Did you get that?
What is it?